All right, here we go. Here we go. So now we're going to talk about binomial coefficients. Pascal's triangle is great to find those coefficients in a binomial if you're only trying to find, like a plus b to the seventh or maybe to the eighth, right? But what if you want to find like the 100th row of Pascal's triangle? That would mean you'd have to know the 99th row before that to get to it, and that is just insane. You're not going to do that. So there is another way to get Pascal's triangle, and I'm going to show you how to do that. The first thing we have to do, though, we do have to make sure we understand what a factorial is. This is called a factorial. You can write it like this, 1 times 2 times 3 all the way up to n. A lot of times I like to actually write it like this, n times n minus 1 times n minus 2, all the way until you get down to 3 times 2 times 1. Since multiplication is commutative, it doesn't matter which way you write it. 0 factorial is 1. So, okay, understanding that, it's just basically a law that says you can find any binomial coefficient if you use this right here, which is called n choose r. We say n choose r. It's also a combination. C, not a permutation, but a combination. So n choose r, and it's found by this equation right here, n factorial. Okay? So n factorial over r factorial times n minus r factorial. So let's go ahead and see how that kind of works out for us and plays out. So if I wanted to first do just 9 choose 4, I would first do 9 factorial over 4 factorial times 9 minus 4 factorial. So 9 factorial, 9 times 8 times 7 times 6 times 5, 4, 3, 2, and 1 over 4 factorial times 5 factorial. And if you notice, this right here is going to be the same thing as 5 factorial. So these are going to simplify out. Okay. Then you could say 4 factorial is 4 times 3 times 2 times 1. Well, 4 times 2 is 8. And 3 goes into 6 twice. So 9 times 7 is 63. 63 times 2 is 126. That's how we get 126. You could do 100 choose 3. So again, 100 factorial over 3 factorial times 100 minus 3 factorial. If you think about 100 factorial, it's 100 times 99 times 98 times 97 factorial, because 97, 96, 95. 100 minus 3 is 97 factorial, so these guys will simplify. And then 3 factorial is 3 times 2 times 1. 3 goes into 99 33 times. 2 goes into 100. 50, if you take 50 times 33 times 98, you get 161,700. Now this is kind of an interesting little phenomena here that's going to happen. Watch this. 100 factorial, 100 choose 97. So 100 factorial, which would be 100 times 99 times 98 times 97 factorial over, we have 97 factorial there. 100 minus 97 is 3 factorial. So these guys will simplify. 3 factorial is 3 times 2 times 1. 3 goes into 99 33 times. 2 into 100 is 50. And if you remember correctly, we just multiplied those three together to get 161,700. So in other words, these two are exactly the same. Whether you choose to do 100 choose 97 or 100 choose 3. Now, interesting about it, 100 minus 3 is 97. So there is a rule out there that says n choose r is the same as n over n choose n minus r. So in other words, that's it's interesting. So let's see how that works. Let's look at 25. Slide 25. If you do these out, 5 choose r, you're going to get 1. 5 choose 1, you get 5. If you do these all out, you get this. Now, you should look at this and say, man, we've seen this, I swear, somewhere before. If I look at Pascal's triangle, take a look. 1, 5, 10, 10, 5, 1. So, in other words, we can get these coefficients that are in Pascal's triangle by just doing this combination of 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. It's as simple as that. All right, let's go ahead and take a look at 26. So we could write Pascal's triangle up like this. And there it is. So, how does that help us out? Well, you know what? I think I'm going to stop here. I'm going to show you one more video how this helps. Actually, let's just go to 28. The binomial expansion theorem. So it's saying that we can take any binomial and expand it by finding these as the coefficients. Now, notice here that this n is where this a starts, because that's our first term, a to the n, and then n minus 1, n minus 2. Back here we have b to the n, then working your way back. I want you to notice something here, folks. Please note. Take note. Special note. This n here, exactly the same. N minus 1, n minus 1, 2, 2. That b is 2, a 1. That's a 1. So the n on top is the exponent. The 1 on the bottom is what your b is. And we're ready to rock and roll. So it says use the binomial expansion to expand x plus y to the 4th. So we could say this is 4 choose 0, first term, x to the 4th, y to the 0, plus 4 choose 1, x to the 3rd, y to the 1, plus 4 choose 2, x squared, y squared, plus 4 choose 3, x to the 1, y to the 3rd, and then 4 choose 4, x to the 0, y to the 4th. Again, those match. So 4 choose 0 is 1. So this would be 1x to the 4th. 4 choose 1, remember that's 4 factorial over 1 factorial times 4 minus 1 factorial, which would be 4 times 3 factorial over 1 factorial times 3 factorial. These would simplify, giving us just 4 x cubed y. 4 choose 2, that's going to be 4 factorial over 2 factorial times 4 minus 2 factorial, which is really just going to be 4 times 3 times 2 factorial over 2 factorial times 2 factorial. So that will simplify. 2 is 2 times 1. 4 times 3 is 12. Divided by 2 is 6. X squared, y squared. 4 choose 3. Well, 4 minus 3 is 1, so it's going to be the same as 4 choose 1. You can check it out. 4 factorial over 3 factorial times 4 minus 1, or 4 minus 3 factorial, which this is just 1 factorial. 4 factorial is 4 times 3 times 2 times 1 over the 3 factorial, which is going to simplify that. 4 over 1 is 4. That's x cubed, or x to the 1, y cubed. And then 4 choose 4 will be the same as 4 choose 0, which is just 1, y to the 4th. And you're done expanding. To be honest, I'm going to be straight up honest with you guys. Straight up honest, okay? Anything that's below almost like 7 or 8, I'm going to choose to use Pascal's triangle. It's just that simple. So 5, I would use Pascal's triangle personally. You can use the other one. And of course, if they tell you that you have to, you better make sure you know how. But for me, if I'm just expanding it and they don't ask and they don't tell me how to do it, I'd use Pascal's triangle, because to get to the 5th row is a lot easier than doing all those 5 choose 0s. So I get 1, 5, 10, space, 10, 5, 1. And then you're just going to go ahead and plug in. Start with 2x. So it's going to be 2x to the 5th, 2x to the 4th, 2x to the 3rd, 2x squared, 2x to the 1, then 2x to the 0. Then I take negative 3. This can be negative 3 to the 5th, negative 3 to the 4th, negative 3 to the 3rd, negative 3 squared, negative 3 to the 1, negative 3 to 0. 2 to the 5th is 32. 32 times 1 is 32, x to the 5th. 2 to the 4th is 16, times 5 times negative 3 to the 1, which is negative 3. So negative 3 times 16 is negative 48. 5 times negative 48 would be negative 240, x to the 4th. 2 to the cubed is 8. Negative 3 squared is 9 times 10. 8 times 9 is 72 times 10 is 720, x to the 3rd. 2 squared is 4th. Negative 3 to the 5th, or sorry, negative 3 to the 3rd would be negative 81 times 10. 4 times negative 81 would be negative 32. That's 27, sorry, not 81. Whoa, whoa, whoa. Hold your little horses. That'd be negative 27. Times that by 10. 4 times negative 27. 4 times 7 is 8. Bring up the 2. 4 times 2 is 8 plus 2 is 10. 108 times 10 is 1,000. So negative 1,080 x squared. 2 to the 1 is 2. Negative 3 to the 4th. Now that's 81 times 5. 5 times 2 is 10. 10 times 81 is 810 x. Negative 3 to the 5th is a negative 243. So that's how I would expand it, but you could have used the binomials if you'd like. Okay? Now, granted, it is true. It's extremely true that it's going to be so much easier if they ask us a question like this. If they say, okay, look, we want you to tell us what is the x to the 5th term in the expansion of 2x plus y to the 20th. Oh, baby. So, here we go. A couple things I want you to recognize, okay, and note. Take note here. I want you to notice this. 5 plus 0 is 5. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. 0 plus 5 is 5. So, what that tells us is that we know that the exponents have to add up to be, in this case, 20. And we want x to the 5th. So this 2x right here is going to be to the 5th, which means this y has got to be to the 15th. And then remember, we're going to take 20, choose whatever this number is here, which is 15. So that's going to give us 20 factorial over 15 factorial times 20 minus 15 factorial times 2 to the 5th, which is 32, x to the 5th, y to the 15th. So that's going to give us 20 times 19 times 18 times 17 times 16 times 15 factorial over the 15 factorial times 5 factorial. So the 15 factorial goes away. 5 factorial is 5 times 4 times 3 times 2 times 1. 5 times 4 is 20. 3 times 2 is 6. 6 goes into 18, 3. So I really need to take 19 times 3 times 17 times 16. So if you take 19 times 3 times 17 times 16, you get out 15,504. And then you multiply that by 32, x to the 5th, y to the 15th. So multiply that by 32, and we get out 496,128, x to the 5th, y to the 15th. Take a look. That's exactly what it is. Okay? We're good. Now, let's take a look here on this last one. Find the term that contains x to the 3rd. Now notice x is back here in the back. So I'm going to have negative x because it's a minus x to the 3rd. That means the 2 is out here in front, and it has to be, they have to add up to be 8. So this is a 5. So 2 to the 5th times negative x to the 3rd. This is going to be 8. Choose whatever that number is there, which in this case is going to be a 3. So I get 8 factorial over 3 factorial times 8 minus 3 factorial times 2 to the 5th, which is 32, negative x to the 3rd, which is a negative x. So I really get 8 times 7 times 6 times 5 factorial over 8 minus 3, which is 5 factorial, so those will simplify, and the 3 factorial here, which is 3 times 2 times 1. Well, 3 times 2 is 6. That goes there. 8 times 7 is 56, so 56 times 32. So if you take 56 times 32, you should get 1792, and it's then times a negative, so negative 1792 x to the third. And let's see. Here's what we get. All right, folks. That's it. Hope that helps. Have a great day. See ya.